Hello, here's the first few questions that I've gotten from the homework. I'm just going to walk through these real quick and upload a video for you. Will someone email me if you get a notification that I responded to this discussion board? I'm trying to find the best way to post this, if I post it as a separate thing or if I just do it right in that discussion board so it's all right there. So here's the first few questions that I've gotten. Number 21 was the vertical plane intersects the front and left faces of this cube. So if I want to take this cube and go through a vertical plane, so you need a vertical line through the front and a vertical line through the left face. I want to go top to bottom on both of those, connect those endpoints, and then your plane will look like that. So that's 21. 25B, a vertical cross-section that contains the vertical line of symmetry. So basically what they're saying is if you're going to cut this figure in half, which would be right here, and you went vertically through that like this, what cross-section would you get? And if you think about it, on this one, when you draw that in, that whole middle section isn't going to have anything. So your cross-section would really be the piece on the left and the piece on the right with empty in between. Okay, so this would be what that cross-section would look like. Because you got to just think you're cutting a plane, nothing three-dimensional about it, right? Just a plane right through the middle of that. Number 30, the plane cuts off a corner of the cube. Number 30, this is the one I showed you guys in class the day that we taught the lesson. If we're going to cut off a corner, I would cut off this corner. And if we cut off that corner, the plane then is going to be a triangle. All right, last few. These ones are just leading you into what you're going to be doing in the next lesson. So this is just for you to be thinking area. But if you think about this, the area of this net, if this is a cube, okay, all these are the same size square. This is a 4 by 4, so the area of that one square is 16, and there are 1, 2, 3, 4, 5, 6 of them, so you would just go 16 times 6. If you're looking here, now this is very intuitive here. You have to really be thinking through what's going on. This circle, the circumference is this length up here. Well, the circumference of that circle is 4 pi. So the length here is 4 pi. So you would go 4 pi times 8, or 32 pi for the area of this piece. And then the area of the circle, oh, they told us that. Gosh, you didn't even have to figure that out. 4 pi. So 4 pi times 8. And then the circle, the area of the circle would be pi times the radius of 2 squared, or 4 pi. So it'd be 32 pi plus 2 of those 4 pi's. Right, so that would be 40 pi square centimeters altogether. And then 62, you're looking at a triangle here. Because they tell you these are the same, then all of these are going to be isosceles. So really you're looking at a triangle with sides of 6 like this. Now you could break that into individual triangles and find the area of just one individual triangle, or you could do the 1/2 AP right now because this is equilateral. I'm not going to take the time to do that right now because tomorrow you're going to learn a better way. But you could do 1/2 AP here if you wanted to do that. Okay? All right, there you go.